Good morning, students. In the previous session, I had proved all the remaining 3 sets of properties. Now, in the remaining sessions, I am going to work out problems connected with all the 3 sets and of course all the 5 sets of properties. Now, let me take the first property, first problem, find the value of the first problem is cot of tan inverse of alpha plus cot inverse of alpha. Now, in each problem, I am going to use any one of the properties. So, sometimes I may have to use 2 properties also. Now, look at this one, cot of tan inverse alpha plus cot inverse alpha. See, from the third set of properties, we have seen that tan inverse x plus cot inverse x is equal to pi by 2. We have proved this result. 3 results we have proved under the third set of property. In this one, this is one of the results. So, here cot of tan inverse alpha plus cot inverse alpha, it resembles a result. So, what you can write here? You can write it as cot of pi by 2, which is a standard value, hence the value is equal to 0. So, this can be expected for a 2-mark question. Directly we are quoting that result, writing the value to be pi by 2 and writing the value of cot pi by 2, that gives you another mark here. Now, let us move on to the next problem. Some problems can be expected for 2-mark question, some can be for 3-mark question. Now, the next problem, evaluate or find the value. Now, and this can be given for a 3-mark question because number of steps would be more in this case. Tan of half of sin inverse of 2x divided by 1 plus x square plus cos inverse of 1 minus y square over 1 plus y square. Close all the brackets. When the problem is containing too many terms here, you have to be extra careful to copy the problem correctly from the question paper. Now, tan of half of sin inverse of 2x over 1 plus x square plus cos inverse of 1 minus y square over 1 plus y square. Now, here from the last property, 5th property, we have learned that one sin inverse of 2x divided by 1 plus x square is equal to 2 tan inverse x. Similarly, cos inverse of 1 minus x square over 1 plus x square is also 2 tan inverse x. There are 3 results in the 5th set of property. All of them have got the same right hand side, 2 tan inverse. It can be expressed in terms of sin inverse or cos inverse or tan inverse. Okay. So, here you observe the first one, sin inverse of 2x over 1 plus x square can be replaced by 2 tan inverse x. That is tan of half of, right inside the bracket only, it is 2 tan inverse x. Now, come to the next one. See, there I have written x, but the same terms are there. Instead of x here, I am having y. So, how do you write this one? It can be written as 2 tan inverse y. So, close all the brackets. Now, take out 2 as common factor. That is tan of half of, taking out 2 as common factor, we will be having tan inverse of x plus tan inverse of y. Now, this 2 and half, they get cancelled. Now, look at the function inside the bracket, tan inverse x plus tan inverse y. See, from the 4th set of property, we have proved a result, tan inverse x plus tan inverse y equal to tan inverse of x plus y divided by 1 minus xy. So, I can write it as tan inverse of x plus y divided by 1 minus xy. Actually, what we am using the property 4. See these numbers, what I have given 1, 2, 3, 4, 5, they are not standard result. According to the notes, according to the way I have explained in the session, no, each session, I am considering that particular number. You need not write that property 4 like that in the answer sheet. So tan inverse of x plus y over 1 minus xy. Again, in the very first session, I had given you one result. Tan inverse could be written whatever number, whatever function, whatever term is there inside the bracket, that could be directly given, because we are considering a trigonometric function and its own inverse function one after another. It is a composite function. Hence, the result will be, the value would be x plus y divided by 1 minus xy. Because it is a little bit lengthy problem, you can expect it for a 3-mark question here. First, what I have done? For the two functions inside the bracket, I have used a standard result here. So they can, both of them can be expressed in terms of tan inverse function. Taking out 2 as common factor, we are getting a function here. For this again resembles another standard result which I have used there. Then using the information tan inverse x is equal to x, I am writing this as x plus y divided by 1 minus xy. Now this is the value of the given function. Now, let us move on to the next problem. In the problems, what I am going to work out now, all of them we are evaluating. In other words, we are either simplifying or finding the value of the given function. Now, next problem, simplify. 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 Here, understand it carefully. Tan inverse of a cos x minus b sin x divided by b cos x plus a sin x. Some restrictions have been given for the values, that is, under this condition, a by b tan x is greater than minus 1. Under this condition, that is, sometimes they give you if. So, you have to simplify this one. Tan inverse of a cos x minus b sin x divided by b cos x plus a sin x, if a by b into tan x is strictly greater than minus 1. Now, look at the function. See, in the problems on inverse trigonometric function, if the outside function is some inverse, tan inverse, sin inverse, try to write the function inside the bracket as the trigonometric function of the same type. Here tan inverse is given, try to express in terms of tan, so that you can make use of the result tan inverse of tan theta is equal to theta. Now here everything is in terms of either sine or cosine. What I do is divide the numerator and denominator, that is inside the square bracket, by b into cos x. Dividing means each term has to be divided, each term of the numerator as well as the denominator. Dividing both numerator and denominator, the value remains unaltered. So divide the numerator as well as the denominator by a common function b cos x. So this would be equal to tan inverse of first term is a cos x divided by b cos x. Then numerator, it is b sin x divided by b cos x. Now here write a little bit lengthy line so that you can avoid confusion between what is numerator and what is denominator. Denominator b cos x divided by b cos x plus a sin x divided by b cos x. Now I have divided both the numerator denominator inside the square bracket by a common function so that the value remains unaltered. Now wherever it is possible to cancel, let me do the cancellation. Cos x and cos x can be cancelled and b can be cancelled. Here both b cos x can be cancelled. Let us see what is remaining now. It is tan inverse of a by b. tan inverse of a by b minus sin x by cos x is tan x. Whole thing divided by b cos x by b cos x is 1 plus a by b, no cancellation here, all the terms now they remain the same. It is a by b into sin x by cos x is equal to tan x. Now look at this one, tan inverse of a by b minus tan x divided by 1 plus a by b into tan x. Now in the property fourth property, we have proved this result. Tan inverse x minus tan inverse y is equal to tan inverse of x minus y over 1 plus xy. Of course, xy is strictly greater than minus 1 under that condition. So we know this property, isn't it? We have proved this one in the fourth set of property. Now look at the right hand, look at the function here. It resembles the right hand side of the result here. Instead of x I am having a by b, instead of y I am having tan x. So I can use the result backwards. I mean, when the right hand side is given, you can express in the form of the left hand side. That is, this is the first term, this is the second term. How do you write that one? You can write it as tan inverse of first function, first term is a by b. Then the second one is tan x minus tan inverse of tan x, using this result. So as soon as you use a result, this result now you quote in this column. Okay. Now tan inverse of a by b, you cannot do any simplification there. So write it as it is. Tan inverse of a by b, here again tan inverse of tan x, that becomes x. So this is the simplified form of the given function. So here outside we were having tan inverse of some function. So naturally you can express the quantity inside the bracket, inside the square bracket in terms of tan function. So automatically tan inverse of tan becomes you can write the exact value whatever you have obtained inside the bracket. So that's what I have done here. First I have done this simplification, manipulation I can say. I divided the numerator denominator by b cos x. Then it comes to a particular form where you can make use of a property which you have already proved. Therefore, it becomes tan inverse of a by b minus x. Now this is the simplified form of the given expression. Now let us try another problem where again we are going to simplify one more expression. Now next problem is simplify again tan inverse of x by y minus tan inverse of x minus y divided by x plus y. Tan inverse of x by y minus tan inverse of x minus y over x plus y. Now here we have to simplify this one. Now you can use the theorem itself. Tan inverse x minus tan inverse y, you can write it as tan inverse of x minus y over 1 plus x into y. You can directly apply that theorem and that property and you can simplify this one. Now if you just look at the terms present in the function, by making some changes here without changing the value, if you could solve the problem in a simplified way, in a better way, we try to do in that way. Now that gives, the first term gives an idea. We are having x by y here. Try to get x by y in the second term also, so that may be helpful for us to solve the problem. If you want to get x by y, what you have to do? You have to divide the numerator and denominator both by y. So that's what I am going to do. It is tan inverse of x by y minus tan inverse of divide each term x by y minus y by y. Whole thing divided by x by y plus y by y. That direct application of the property is also correct. There no, you have to take the LCM and all. No, it may be little bit difficult. So you can follow this particular procedure. So y can be cancelled here. So I can express it as tan inverse of x by y minus tan inverse of x by y minus 1 divided by x by y plus 1. Now denominator I write as it is. The numerator I see, because it is a plus b, I can write that as b plus a, because you know that addition is commutative. A plus b would be equal to b plus a. So I will write in another form without changing the value using the commutative property. So this can be written as tan inverse of x by y, write it as it is. It is tan inverse of, write the numerator as it is, x by y minus 1 divided by, first I am writing 1 here, and x by y I write like this, 1 into x by y, or you can write x by y into y, to be in the particular form only. So what I have done? I have written the numerator as it is, denominator x by y plus 1, I am writing 1 plus x by y, and anything multiplied by 1 would be same. So I am writing 1 plus x by y into 1. Look at the second term here. First one you write as it is, tan inverse of x by y. In the previous problem, I made use of the property for tan inverse of x minus tan inverse of y is tan inverse of x minus y over 1 plus xy. Now this resembles the same thing. In the place of x I am having x by y, in the place of y I am having 1. So because of the negative sign, write another inside the bracket. That can be written as tan inverse of x by y minus tan inverse of 1. So I am using the fourth property. Always make it a habit to quote the result, whichever result you are using in the working column. Now remove the bracket. Tan inverse of x by y minus tan inverse of x by y. Now minus of minus plus, it is tan inverse of 1. You observe these two are cancelled. Tan inverse 1 is a standard value, the value being pi by 4, or it is equal to 45 degrees. So I am using the one or the other property to arrive at the result. So this is the value tan inverse 1 equal to pi by 4, since tan pi by 4 is equal to 1. Okay. Now let's move on to the another problem. See, in all these problems some expression is given. I am just simplifying the expression. If I could evaluate that one, I am getting the value, or I am just finding the, I am writing it in a simplified form, that's all. Now let's move on to the next problem. One condition is given here. If mod x is, if modulus of x is less than 1, find the value of sine of tan inverse x. This can be given for a 2-mark question, that's all. If mod x is less than 1, you have to find the value, or you have to express this in another way, sine of tan inverse x. Now x is an unknown number here. So what I do for this problem is, I make an assumption here. Let tan inverse x be equal to theta, because you know that any inverse trigonometric function always denotes an angle. So this theta is some angle. Let tan inverse x is equal to theta. Now using the definition of the function, how do you write this one? Tan theta could be written as x. A tan theta being a trigonometrical ratio, I write x in the form of a ratio. I can write it as x by 1. Now let me write a right angle triangle. Because all the trigonometric ratios we have defined using a right angle triangle. Tan theta is equal to x. How do you define tan theta? Opposite over the adjacent side. So this is x opposite, 1 is the adjacent side for the angle theta. So using the Pythagoras theorem, see the two sides are given, you have to get the value of the hypotenuse. That is sum of the sum of the squares of the sum of the square of the hypotenuse. Square of the hypotenuse is equal to sum of the squares of the other two sides here. So using that particular theorem, I can write this as square root of 1 square plus x square, or it is square root of 1 plus x square. So x 1 and root of 1 plus x square. Now let us come to the problem. It is sine of tan inverse x. That is what I had considered. Now what is tan inverse x equal to? It is theta. I have made an assumption. So I have to get the value of sine theta. Again refer to the triangle here. How do you define tan theta? Opposite over the hypotenuse. Opposite is x. The hypotenuse being square root of 1 plus x square. So the value of the given expression sine of tan inverse x is equal to x divided by square root of 1 plus x square. So in all these problems so far I had considered, I was evaluating, or I was simplifying the given expression. Now we are going to work out some more problems where most of the problems I am going to prove certain result. That is, prove the following. Some may be for a 2-mark question, or some may be for a 3-mark question. First one, prove the following. It is sine inverse of 2x into root of 1 minus x square should be shown to be 2 into sine inverse of x. 2 into sine inverse x. The value of x is has been given here. The value of x should lie between minus 1 by square root of 2 and plus 1 by square root of 2. Now this is again a 2-mark question here. Sine inverse of 2x into root of 1 minus x square should be shown as 2 into sine inverse x. See, sometimes they ask you prove the result. Prove the result means you have to always start with the left hand side, show that it is equal to right hand side. Maximum number of problems. Sometimes we have done in the earlier session also, sometimes we start with the right hand side, show that it is equal to the left hand side. Sometimes we may have to simplify both LHS and RHS and show that they are equal to each other. Now in this one, look at the right hand side. That always gives you an idea how to start with. That is little bit easier. To prove a result is easier because always the right hand side gives us a clue how to start with. Now sine inverse of 2x into root of 1 minus x square. Let me make an assumption here. Let x be equal to sine theta. Then see this assumption we make only to simplify or to prove certain result. Always you have to go back to the original variable x here. So as soon as you make the assumption x equal to sine theta, you immediately write what is theta. Theta can be replaced in the end by sine inverse x. Now let us start with the left hand side because we are proving a result here. That is sine inverse of 2 into, what is x here? X is equal to sine theta into root of 1 minus sine square theta. Root of 1 minus sine square theta. That is equal to sine inverse of 2 into sine theta. See, we have learned from the first identity, sine square theta plus cos square theta is equal to 1. So 1 minus sine square theta could be replaced by cos square theta. Cos square theta. Now sine inverse of 2 into sine theta into taking root of this one, it becomes cos theta. So here what property I have made use? Here I have made use that sine square theta plus cos square theta is equal to 1 using the first identity of trigonometry. Now look at this one. Sine inverse of 2 sine theta into cos theta. What is 2 sine theta cos theta? It is the multiple angle formula I am using. So 2 sine theta into cos theta is sine of 2 theta. Again you can quote that in the working column. since sine of 2 theta is equal to 2 sine theta into cos theta. Okay, now here we are having an inverse function, we are having a trigonometric function. So using our knowledge about this one, I can write it as 2 theta. Come to this one, assumption. What is theta? It is sine inverse x. So I get the result here, 2 sine inverse x, which is the right hand side. Now this problem has been asked in the earlier examination for a 2-mark question. So always look at the right hand side. Depending upon that one, we make an assumption here. So let x be equal to sine theta. So theta can be finally replaced by sine inverse x. Then wherever x is there, write that value. I am using the identity. So I get here root of cos square theta. I am using the multiple angle formula and using the sine inverse of sine x would be x here. I am getting 2 theta, which is nothing but 2 sine inverse x, which is the right hand side we wanted. Now, in the next problem, the left hand side is same, but right hand side is different. That is, same thing, sine inverse of 2x over root of 1 minus x square. I have to prove that this is equal to 2 times cos inverse of x. And the value of x also is different here. It is 1 by root of 2 less than or equal to x less than or equal to 1. So the value of x would be usually given. So sine inverse of 2x into root 1 minus x square. The left hand is same for the previous as well as for this problem. But the right hand side is different. Here you have to prove that it is equal to 2 cos inverse x. Now in the earlier problem I took it as sine theta. So what I should take now? I have to take it as x is equal to cos theta. So here what happens? Theta becomes cos inverse of x. Theta becomes cos inverse of x. Now let us write the value of theta. Let us write the value of theta here, that value of x here in terms of theta. 2 into cos theta into root of 1 minus cos square theta. Root of 1 minus cos square theta. Now 2 into cos theta. See, in the previous problem I had 1 minus sine square. So I replaced it by cos square theta. Here I am having 1 minus cos square theta. I am using the same identity. It can be written as square root of sine square theta. Square root of sine square theta. What is root of sine square theta? It is again sine theta. 2 cos theta into sine theta. The same thing we are getting here also. So 2 sine theta cos theta using the multiple angle formula, that is again equal to sine inverse of sine of 2 theta. So same result you can quote here also. Sine inverse of sine 2 theta is 2 theta, which is nothing but 2 cos inverse x. Okay, in the previous problem we had sine inverse x because we have to show that it is equal to 2 sine inverse x. So I had taken the substitution as x equal to sine theta. Here I have taken x is equal to cos theta. So finally we arrive at the result 2 into cos inverse of x. Okay, we will work out some more problems in the next session. Thank you.